Welcome to this video on polar coordinates. In my many years of teaching engineering statics, I have found out that students have significant amount of difficulty in writing a force vector when the force is described in a polar coordinate. Before we get to the theory and examples, I would like to draw your attention to this textbook where you will find many solved examples, and also to this software which will help you solving all kinds of engineering statics problems. Let's start with the general equations before we get to the examples. So here what we have is the right-handed coordinate system and a right-handed coordinate system. And I'm going to show you two examples simultaneously, or develop the theory in two situations. In one situation, the force is above the xy plane, and in the second situation, the force is below the xy plane. And there are some subtle differences that you will have to keep in mind, although once you understand the theory behind the general equations, whether the force is above the xy plane or when the force is below the xy plane, doesn't make much of a difference, but I would like you to pay attention here. First, in polar coordinate, the first piece of information that is given is the angle between the force and the z-axis, which we call theta z. And you will notice that when I develop this theory or the general equations for polar coordinates, I always use the cosine function. And you have learned from your lessons on direction cosines, the cosine function is the easiest way to write a component. So you have a force, you want to find its component along the z-axis. The first question you ask is, so what is the angle between the force and the z-axis? And if it's theta z, then the z component of the force is magnitude of the force multiplied by cosine theta z. That's the first step. So now we have the z component. What do we do next? We drop a perpendicular from the tip of the force onto the xy plane. So here, this is the perpendicular. The foot of the perpendicular on the xy plane is q. And the same thing happens here. From the tip, we have dropped a perpendicular, and the foot of the perpendicular on the xy plane is point q. Then we join the origin and q. Then we ask, what is the angle between the force and the line OQ? And that's alpha. Again, we use only the cosine function. If the angle between the force and line OQ is alpha, then OQ is f cosine alpha. Notice one thing, that I am not going to bring in the sine function at all, because I have seen from the direction cosine idea that cosine is a very convenient way of writing components. So once you have OQ, then you ask, what is the angle between the line OQ and the x-axis? If that is beta, then x component of the force is OQ cosine beta. Again, don't get into cosine and sine. Just stick with cosine all the way through. Now we need the y component. So we ask, okay, what is the angle between OQ and the y-axis? If the angle between the OQ and y-axis is gamma, then the y component is simply OQ cosine gamma. So, four-step process. Theta z is given, find fc using the cosine function. The angle between PQ and angle between the force and the line OQ is given as alpha, find OQ. Angle between OQ and x-axis is beta, find fx. Angle between OQ and y-axis is gamma, find fy. Let's look at some examples. So here we have a 700 Newton force, and Q is the foot of the perpendicular, and the angle between the xy plane and the force is given as 75 degrees. So the angle between the force and the z-axis will simply be 15 degrees. So theta z is 15 degrees, and we found fz. The angle between the force and line OQ is 75 degrees, so we can find OQ as 700 cosine 75. Now the angle between the line OQ and the x-axis is given as 60 degrees. So we can immediately find fx as OQ cosine 60, 90.59 newtons. Now let's find out what is the angle between the line OQ and the y-axis. The angle between line OQ and the y-axis is, first you go 60 and then you go another 90. So the angle between OQ and the y-axis is 150. And that gives you the y component. Notice one thing, that I calculated everything by using the cosine function, and this cosine 150 actually gives you the negative sign. You do not have to do anything special, and that's why I do not use sine functions. The cosine function automatically gives you the positive and negative signs appropriately. Next example. The angle between the force and OQ is 30. From OQ, you will have to go another 90 degrees to the z-axis. So the angle between the force and the z-axis is 30 plus 90, 120. Just because I'm using the cosine function only, the force is below the xy plane, which means the force has a negative z component, and the cosine function gave me that negative sign for fc. Angle between force and OQ is 30 degrees, so I can calculate OQ as 80 cosine 30. So now we know the value of OQ. The angle between line OQ and y-axis is given as 20. So the angle between line OQ and the x-axis will be 90 degrees minus 20 degrees. So that's 70 degrees. And you got your fx. angle between OQ and the y-axis is 20 degrees. So we simply write OQ is cosine 20, 65 pounds. Thank you for watching.